At the base of this Samsung front-load washer, you're looking at the core of its drive system, the rotor and stator. These two parts form the direct drive motor, which is responsible for spinning the drum. The rotor is the outer magnetic ring that attaches directly to the back of the washer drum, while the stator is the inner stationary coil assembly mounted to the tub itself. Together, they generate a rotating magnetic field that drives the drum directly, no belts involved. The shaft, which is bolted to the center of the drum, connects it all. When current runs through the stator windings, it creates electromagnetic forces that spin the rotor, which in turn rotates the drum via the shaft. This design allows for high-speed spinning, quieter operation, and greater energy efficiency compared to older belt-driven systems. Also located in this area is the Hall sensor, sometimes called a rotor position sensor. It's mounted near the stator and detects the position and speed of the rotor as it spins. This feedback is sent to the motor control board, which constantly adjusts power to the stator to keep everything running smoothly. Now, powering and coordinating all of this is the motor control board. It's typically mounted low in the washer cabinet, close to the stator. This board receives input from the Hall sensor and manages how much voltage and current goes to each coil in the stator, depending on the washer's cycle settings and load conditions. It doesn't work alone, though. The motor control board is just one part of a larger system. Above it, usually located near the top rear of the washer, is the main control board. This is the washer's brain. It interprets user commands from the front panel, monitors sensors throughout the machine, and tells the motor control board when to start, stop, accelerate, or reverse the motor. For example, during the spin cycle, once the washer has drained the water, the main board will command the motor control board to initiate a high-speed spin. The motor control board then sequences power to the stator in phases, allowing the drum to accelerate smoothly without jolting the machine. The seamless coordination between the boards, Hall sensor, and motor allows for fine-tuned speed control, energy efficiency, and better balance detection. It also helps protect the machine. If the sensor detects abnormal resistance or speed fluctuations, the system can shut down or reduce speed to prevent damage. So when you look underneath a Samsung front-load washer and see this array of coils, magnets, boards, and sensors, you're looking at a finely tuned electrical and mechanical system. The stator and rotor may be the most visible parts here, but they're just one piece of a broader architecture. The Hall sensor ensures real-time precision. The motor control board constantly adjusts performance. And the main control board orchestrates every cycle, from soaking to spinning. It's not just about washing clothes, it's about managing torque, speed, vibration, and timing across multiple components working in perfect sync. If any one of these components fails, say, a worn Hall sensor or a fried motor control board, it can throw the entire system off. That's why, when diagnosing issues like a drum not spinning, strange noises, or error codes, it's critical to understand how each part fits into the bigger picture. In the end, it's this hidden ecosystem at the base of your washer that makes the entire machine function with the precision you expect. And now that you've seen inside, you'll never look at laundry day the same way again.